Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, I'm going to talk about OSIRIS-REx. So let's dive right into it. Well, first you have to understand this is a different kind of mission because most of our mission is just go there and study the damn thing. This is a sample return mission. So basically we're gonna go there and pick something up and bring it back to Earth. So it's a different kind of mission. Now this is first time for USA, but be mindful when I'm saying first time for USA, this type of mission, because USA have done the biggest sample return mission known as Apollo program, because we do not think about it, but like the amount of lunar material they brought back, that's GG amount. So fundamentally USA is like on a top enough where it's like they don't have to worry about it. But from asteroid, this is the first time USA is doing it. Japan has already done that with Hayabusa mission. However, the material collector was very little, but again they have the first claim. So what they are gonna do, so they're gonna go to the asteroid, they're gonna orbit the asteroid. So asteroid was very specifically selected. There is some mathematical potential of doing proper orbit, so they can study it much more thoroughly before tapping it. Now why tapping it? Now this is one thing you have to understand. When you're seeing this arm, you may see like they do not look very strong. You have to understand the sole reason we can dig on Earth, quote unquote dig on Earth, is because Earth has gravity. So whenever you take a shovel and you go on the ground does not throw you away, simply because gravity is acting as a kind of magnet. Basically it's gluing you to the ground. That will not happen. So if you take a shovel and you're like you did that, you will bounce back because there is no gravity to anchor you. So action equals reaction will happen, and that will literally be bad for a spacecraft. It will like go tweet. So you don't want to do that. So it's tap, it's very gentle. They will try to be as gentle as possible, and then they're gonna try to collect as much as possible, and then they're gonna leave. So this is why tap and go has been classified. Now it has a high resolution cameras on 3 systems, like a telephoto, medium range, and ultra wide. So nowadays cameras are pretty standard. It has visible and infrared spectrometer, so they can do a thorough study of the material before they actually tap something, because you have to understand they are tapping and their mathematics suggest they will go a bit deeper than surface. So they have to study it much more thoroughly before they are like, dude, I directly collected something uninteresting. So these instruments will help them that. And then there is a regolith X-ray imaging spectrometer. This will allow them to do much more thorough analysis, as in like what exact element is in the goddamn thing, on a much more thorough level. We'll like, no, all of these instruments will help you to make a complete detailed picture where like what exact element is there. And be mindful the fact that regolith X-ray imaging spectrometer, it's been made by students from MIT and all that jazz. So surprisingly interesting thing. It's this big, like a shoebox size. So that's what we are talking about here. Now, launch of this puppy happened in September 8, 2016. So it's kind of old system. ULA, United Launch Alliance, launched it on Atlas V 411 configuration, meaning it was main system and 1 solid booster. So it was doing Tokyo drifting when it was launching, and it did whole orbit of Sun, and then it got Earth assist on 22 September 2017. Now this was done to again give it a bit more oomph, and it has another advantage. It allowed whole mission team to do calibration on every single equipment, because Earth is a known target. So if you are training your cameras and you can, if you see Earth and Earth instead of looking blue it looks yellow, you're like, dude, our sensors have messed up. So for that reason calibration was it was like a win-win scenarios. Like you're gonna get a gravitational assist, you're gonna train all your equipments to be like calibrated. So super awesome thing. Then on 3 December it finally catched up to Bennu in 2018. At that point NASA declared that it's at a position where it's like, no, I'm been this far away from Bennu, it's not going away or coming closer, it's like I'm parked, quote unquote parked. So they started to do the orbit. Now you have to understand this part. At this point in time Bennu was very thoroughly studied with using what we classify as radio telescopes, and it does work. We got the raw size of it, and once the Bennu became basically the spacecraft reached close enough and the telephoto lenses started to gather picture, rough shape matching, awesome. But the moment we start to get actually close to it, it was like, what the hell happened here? It's like they were expecting smooth sandy beaches. That's what they were expecting. Like you will see NASA's old press conference, they were like, we are expecting this kind of area, smooth sailing and all that jazz. And once they actually, dude, it's Himalayan range. It's like very rocky, very bumpy. It's like, what the heck? Because again, radio is not that high resolution. So once they actually went there, it's like, what the heck happened? It's like, think of it this way, like it's your airport directly disappeared and you ended up with a parking lot to land. So that happened. So that's why there is a giant gap between 3 December 2018 to actual doing the touchdown that happened in 20 October 2020. During this time, not only they did multiple orbits to study it thoroughly, it's like, okay, we got this, let's figure it out, like let's first use all our instrument to map this properly. And they did the mapping. During this time, a navigation update was created and they ported that data into the system. Spacecraft basically got a rudimentary AI at that point in time, so where it can do self-based calculation using natural feature tracking system. It's like, okay, this boulder is here, I'm going to utilize this boulder as an anchor point, this boulder for orientation, this boulder for this, and then on its own data point, because there is no way to do faster than light communication yet. So you had to do that because remote controlling would not be possible at 18 light minutes of lag. So fundamentally they had to do that. So all these things were happening from 3 December 2018 to 20 October 2020. And before this, they did a lot of rehearsal before, like, okay, let's go closely, let's see how things works out. So, and be mindful, this asteroid is kind of active, so it had a issue where it like poop and a lot of rocks left it out. So it was very weird kind of scenario. So once they have done that, because 20 October 2020 has already passed and that was done, we got all the data from it, it's like everything is go, the tap and go is successful. Now it's waiting for basically return window, and return window will appear for it on March 2021. So yes, we have to wait a long time. After that, it will start to like its journey back to Earth, and by 24 September 2023, it will re-enter Earth's atmosphere. So by August, we should know whether did it actually succeeded or not on 2023. So yeah, it's still a long way to go, but all the major accomplishment has been done. So let's understand the asteroid Bennu aspect of it. Now, one thing you have to understand, when NASA is shortlisting anything, it's like, okay, this is 10,000 asteroids we know about, let's figure it out where we want to go. There's a lot of criteria, like, okay, we can only go to this. NEO was the first thing, near Earth orbit, meaning our rocket should actually able to carry it. You can see it was using Atlas 5, it was not using Delta 4 Heavy or something like that. It did not require very GG amount of rocket, which kept the project cost down. So that was first requirement. Can we actually go to there? So it's not like, okay, go to Pluto and wait for 10 years now. Can we actually go there, come back? Because coming back is also important here. So that was a very serious thing. Another aspect, this is potentially hazardous object. Now it's a dual-edged sword. We are tampering with something that is 510 meters in diameter, and it can go boom to Earth in around 150 years if things misalign, so to say. So fundamentally, it's a, we have to know about this, but again, we might cause our own demise just trying to know about this. So it was like a double-edged kind of sword, but people sort of like, we have to know, better to know and understand this rather than be like, okay, maybe it does not collide with us, but if it collides at that point in time, you would know, like how you would like to know what exactly was the composition, so you can create a countermeasure. So fundamentally, it was decided that even though this is a what we call potentially hazardous object, we should study this because potentially hazardous. And it's a carbonaceous asteroid. There are many asteroids that are made of ice. Not that interesting. Carbonaceous. Now the interesting part of it is when stellar systems are created, as in like when gas cloud goes boom, there is an excretion disk, so to say, and this disk collapses in itself and makes planet. At that point in time, lot of heavy elements become into something big, sometimes planet, sometimes moon. Things of this nature happen. This is normal thing. However, minerals that are forged in that times, so they will go from gas to actual solid, those are first generation elements, so to say. Now those are generally, even though you can find, again, most of Earth is made of those things, quote unquote, but they're never what we call oldest or untouched, because you can find a rock that is like at the beginning of the solar system, but if it's on a planet, there's a very good chance it was some point below Earth's surface, like as in like 1 meter below or 10 meter below, or maybe rain has happened which has eroded it. So there is so many processes which kind of tampers with it. So you can find a rock that is like tangibly absolutely from the beginning of the solar system, but it will not be untouched. So you have to recalculate what would have happened if it was like molten lava was going here, what would happen if let's say rainwater was going here. So you can understand that. So we do have rocks from that point of time, but we do not have what we call untouched and oldest system. So for this reason, this puppy was very, very interesting. Now it already, because we have already studied it with all the equipments that we have, it does have symptoms or signs of early building blocks of life, aka carbon, aka organic chemistry. So fundamentally that is another aspect. And so you have to understand that this carbonaceous asteroid is far more interesting rather than the Bennu asteroid. The whole reason Bennu has been taken care of, it's like if you have two asteroids and both of them are unknown, but 50% about Bennu rather than 0% about another asteroid, NASA was like, yeah, we'd rather take our bet on something that at least we have some clue about. And NASA made a surprisingly hilarious childish video about this, and I have provided the video down below. I would urge you to check out. As like, we have this many candidates, then it candidate went from 1100 to 100 to 35 to 5 and 6, and then this was the final candidate. So it's more like selection bias rather than like, oh, this is actually the most interested, most greatest thing ever. No, it's like a selection kind of scenario. However, it's one of those things which we have already observed. So there was like something, we knew something about this, so we took a big gamble to it, 510-meter gamble. So what about the sample, the actual mission, so to say? Now this is the smallest body which we have till this point in time. We should most reliably should exceed this point somewhere in the future, but as of now this is the smallest object that we have successfully orbited multiple times. So this is awesome, and given the equipment quality that this puppy had, lot of high resolution map has been created. At this point in time, NASA is flat out claiming that the map detail, given the surface area and given how much detailed map you have, it exceeds Moon, Earth, Mars, everything. Basically, we do not have a map that even comes close to this level of accuracy. It's like we know every single pore of this puppy. So we did tap, load, and go. Now tapping, that was done very gently. It's like, go there, just tap it. Now loading part, this is the interesting part, because they could not like scoop up or something like that. They utilize high pressure nitrogen. Now because of this baffle and the way the system is designed, the nitrogen will go from basically high pressure chambers. It will go and it will scoop up the material, and then it will leave out. Now the way it's leaving out, there is a mesh there, so gas can leave out, but material will get stuck there. So that happened, it worked, everything was awesome. The terrain was much rougher, so that's why like the whole is like, oh, sandy beach to like, wait a minute, we thought we had like 100 parking spots to like 5 or 6 parking spot with giant boulders. So if your angle is off, the end. So Mount Doom, there is an actual mountain name on this puppy, that is Mount Doom, because of that. So very rough terrain, but it was very successful. Unfortunately, it was very, very successful. So the moment the mission was done, and they're like, okay, let's look at it with a camera. They had 3 gas bottles, so they could do 3 attempts. So there was like, again, they designed it with that way, and they see the basically arm equipment, and it's like, well, the door is not closing. Why? It is full with material, and at this point in time they are in a partial vacuum, as in like a low gravity environment, and material is pouring out. So they're like, we have enough material, but the door is not closed, so it's leaking out. So everything at this point in time, the moment this footage reached to NASA is like, okay, stop every single motion on the damn craft. So it does leak very slowly, and first thing they figure out, like, what the hell we have to do, because original plan was they're gonna collect the material, close the door, and then they're gonna swing arm it, and using the inertial measurement unit, they will figure out how much mass is collected here. They decided against it simply because it's leaking. So going whoosh on it, you may lose everything you have collected, and you may have already damaged this. So where second attempt or third attempt is not possible, and not to mention it's very dangerous. Like that spot they selected, like they spent years trying to find a small spot. So they're like, yeah, okay, we know we have it, like that's known fact. We know for a fact that we have something, and they know with analysis that they are exceeding the 60-gram target. 60 gram was the green zone. Basically, if you got 60 gram, GG. And they are reasonably sure they have much more than that. So they're like, okay, go. So all they did is just like pack it up. Don't try to measure it, don't try to analyze, just pack this puppy up. So because it's a mission, and it's a long duration mission, and it has to go somewhere and land, it has hydrazine monopropellant system. Simple, effective, reliable, and they have like around 1 ton of 1.4 ton I think of hydrazine to do all this mission. Now sample return capsule was like, they saw it, they're like, okay, just put it there gently. They locked it, every system checks out. So at this point in time, this puppy is loaded, everything is go, and they're gonna do during the Earth's transit, they're gonna drop it into Earth, so to say. So this puppy will become one of those unique space assets that will go to space and come back intact, as in like a robotics kind of scenario. Most of the time, of course, human mission does return, but this would be the first time. As you can see, it's not that big, so they are expecting like at least few 100 grams to maybe even kilogram, who knows. And this will come to Earth using heat shield to make sure it does not melt, because the original Hayabusa, they literally collapsed the whole satellite through it. They knew for a fact that only the capsule will survive, so they did not have to worry. But this is not doing it something like that. So maybe they extend the router if they have any propellant left. So it will use parachute, and it will land safely on Utah missile testing range. So it's a very large patch of empty land, so it should not crash into anything. However, because they have unknown quantity of material, things could go weird direction. So we have the long wait now. So this was my presentation on basically OSIRIS-REx. I hope you like it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.